Just like paper 1, this question paper also contains a lot of easy questions, but some questions involve time consuming tedious calculations. Let's see how it goes. This is a question on basic trigonometry, right? We are given the value of sine alpha plus beta, cos alpha minus beta. Using that, we have to find the value of this long expression, right? So sine alpha by cos beta plus cos beta by sine alpha plus etc., right? So let's simplify this term, right? Yes. So what is given here is this one, sine alpha by cos beta, sine alpha by cos beta plus cos beta by sine alpha plus cos alpha divided by sine beta plus sine beta divided by cos alpha. The square of this we have to find. Let's simplify this first. So what we are going to do is we have to group the terms. We can't add all the terms at once, so we have to group these terms. Let's group these two terms, right? So why do you do that? So then only we'll have this one, sine alpha, sine beta, cos alpha. We have a formula, right? So there is a way to combine them. So let's group these two terms. Okay, yes. So these two you add and these two add separately. So I'm writing directly sine alpha, sine beta plus cos beta, cos alpha. It is like cos A, cos B plus sin A, sin B. So that can be written as cos A minus B. So that will become cos A minus B, cos alpha minus beta. So divided by, so cos beta, sin beta. Similarly, if you add these two terms, again we'll get cos beta, cos alpha plus sin alpha, sin beta. So that is again of the form cos A, cos B plus sin A, sin B. So we will get cos alpha minus beta again. So divided by sin alpha, cos B, cos alpha. Okay, yes. Now, so this value can be taken out, common value. So cos alpha minus beta, here also cos alpha minus beta. So if you take out that value, cos alpha minus beta, so we are getting this one. So 1 divided by cos beta, sin beta. Similarly, 1 divided by sin alpha, cos alpha. So this can be written as 2 if you multiply and divide, 2 sin alpha, cos alpha. That can be written as sin 2 alpha. So this becomes 1 by sin 2 alpha. Similarly, we have here, so 1 by sine 2 beta, okay, multiplied by 2, okay, so we have to multiply this by 2 because this is 2 sine alpha cos beta, right, cos alpha, so that is not there, 2, multiply and divide by 2, so we get this thing, okay, so this value is already given in the question, so cos alpha minus beta is given in the question, that is 2 by 3, so this is 2 by 3 and that 2 can be written here, so multiplied by 2, but this value we don't. So we don't know the value of this sine 2 alpha. So how to find the value of this? We only know the value of alpha plus beta, sine alpha plus beta and alpha minus beta. So what we have to do? We have to write this 2 alpha and 2 beta in terms of the known values. So what is that? Alpha plus beta and alpha minus beta. So what can you write? So here we can write it as 2 alpha can be written as sine of alpha plus beta plus alpha minus beta. Because that is what is given in the question, right? Alpha plus beta, alpha minus beta. If you add these two, we'll get 2 alpha. So that way we can write it. Similarly, so 2 beta can be written as sine alpha plus beta minus of alpha minus beta. So minus. So this if you add, you will get 2 beta. So that's it. So we have to simplify this. Now use the formula sine A plus B. So here also sine A minus B. Use the formula. We'll get the answer. Okay. Yes. Now, yeah. But instead we can try something else, okay, so you just simplify this, cross multiply, so it is of the form sine A minus B plus sine A plus B. So what is the formula? Sine A plus B plus sine A minus B, that is 2 sine A cos B, right? So sine A plus B plus sine A minus B, that is 2 sine A cos B. So that if you write here 2 sine A cos B, so 2 sine alpha plus beta multiplied by cos alpha minus beta. See, you can separately also find this value using sine A plus B formula. There also sine A plus B and then A minus B. Then we can simplify that. But instead, I am just simplifying this beforehand. So cross multiply. So that is sine A plus B plus sine A minus B. That is 2 sine A cos B. So divided by what? So that is sine A plus B multiplied by sine A minus B. What is sine A plus B multiplied by sine A minus B? That is sine square A minus sine square B. So if you remember the formula, so we can write directly also sine square A minus sine square B. So that is the formula for sine A minus B. A plus sine A plus B multiplied by sine A minus B. So that is the formula. See, all these values are known. See, sine alpha plus beta, that is known. Cos alpha minus beta, that is also known. So this value is also known. So that can be simplified. So this is 4 by 3 multiplied by 2 multiplied by sine alpha plus beta. So that value is given. So 1 by 3. So this is similarly 2 by 3 cos alpha minus beta and sine square alpha plus beta. So that is 1 by 9 minus sine square alpha minus beta. We only know cos alpha minus beta, which is 2 by 3. So sine square can be written as 1 minus cos square. So this is 1 minus cos square alpha minus beta. So that is 4 by 9. Okay, so that if you simplify, so what do you get here? So this is 8 by 3 multiplied by, okay, so 8 by 3, okay, so 2 by 9 divided by, so what is this value? So this is 1 minus 9, so plus 5, so that is minus 8, so it is 4 by 9, so minus 4 divided by 9. So this gives you the value, yeah, so what is this value? So this is 2, so 4 by 3, that's it, so minus 4 by 3. So this is the value of this expression only, right? But we want to find the square of this and find its integer part, right? So what is the square of this? So our required answer here is the square of this, minus 4 by 3 square, and also its integer part. Okay, so that is integer part of 16 by 9, so that is 1 point something, so the value is 1. So that's also, that is the answer. So this is the idea that is important. So we have to group these two terms. After that it is simple calculation, right? The basic trigonometric identities, right? So the compound angle formula, so that is used here. So that's all. So that is the method, and the answer here is 1. That's it. So this is a question on differential equation, right? So let us solve the differential equation here. So x dy, so this is the equation given, x dy minus y square dx plus 4y dx equals 0. So this is the differential equation. So what type of differential equation is this? So let's simplify this. Okay, so we get, so this is x dy by dx, and similarly plus 4y, okay, equal to y square. Okay, so that's what, so this looks like the linear differential equation. All right, so dy by dx, if you divide this, okay, it will be a linear differential equation, dy by dx plus p, right? So p is a function of x multiplied by y equal to q, a function of x again. But here right hand side also we have a function of y, right? So y to the power n. So this is called the Bernoulli's equation, if you remember the method to solve Bernoulli's equation. So this is 4 by x y, so that equals y square. Okay, yes, y square by x. Now, so what do we have to do? So this is the method, right? You divide by y square. So if you divide by y square, it will become 1 by y square dy by dx plus 4 by x multiplied by 1 by y equal to 1 by x. Okay, so that's it. Now we have to do the substitution. So take t is equal to 1 by y. Then this is the derivative, right? So minus dt by dx. So this is dt by dx minus, and then this is plus 4 by x t equals 1 by x. So this looks exactly like a linear differential equation. So this you know how to solve, right? Integrating factor and all those stuff, right? So dt by dx minus 4 by x t, so that equals minus 1 by x, just multiplying by, so minus 1. Okay, so now this is our p, minus 4 by x. Now we have to find the integrating factor, and then we have the solution. So what is the integrating factor formula? So e to the power integral, so p dx, so that is minus 4 by x dx. Okay, so that equals e to the power minus 4, so log x. Okay, so that equals, so x to the power minus 4, so e to the power log x to the power minus 4, so that is x to the power minus 4, or 1 by x to the power 4. So that's all. So that is the integrating factor. So what is the solution of linear differential equation? So once you got the integrating factor, solution is y, not yt here, right? So not yt, so t multiplied by the integrating factor, so that is 1 by x to the power 4. So that equals integration of the right hand side, so that is minus 1 by x, right? So that is q multiplied by the integrating factor, so that is minus 1 by x multiplied by 1 by x to the power 4 dx. So that's all. So let us do the integration. We can even substitute the value of t here, which is 1 by y. So this is 1 divided by y x to the power 4, so that equals, so this is minus 1 by x to the power 5, or we can write minus x to the power minus 5. So that if we simplify, we'll get 1 divided by 5, so 4x to the power 4 plus c. So that's it. So this is the solution of the differential equation. Now a particular value is given, y of 1 is 2. So when x is 1, y is 2. So that you can substitute here. So this gives 1 divided by 2 equals, x is 1, so 1 by 4 plus c, that gives you the value of c. C is 1 by 4. So that if you substitute here, we get the exact solution of the differential equation. So c is 1 by 4. So we get 1 divided by y x to the power 4, so that equals 1 by 4x to the power 4 plus c is 1 by 4 again. Okay, so that's it. Now we have to find y of root 2. So when x is root 2, what is the value of y? That's what we have to find. So x is root 2. Substitute x value root 2 here. So if you substitute x root 2 here, this is 1 divided by 4y. So root 2 to the power 4. So that is 4y. So that equals, so this is 1 divided by, yeah, so this is 4 multiplied by 4, 16 plus 1 by 4. If you simplify this, we get the value of y, right? So this is 4 plus 1, 5. 5 divided by 16. If you cancel 4, it is 5 divided by 4. So that is the value of 1 by y. So we get the value of y. So that equals, so 4 divided by 5. So 4 by 5 is the value of y at x equal to root 2. Y of root 2 is 4 by 5. But we want 10 times this, right? So 10 times y. So that equals, so 10 multiplied by 4 by 5. So that is 8. So that's also, that is our required answer. So 10 multiplied by y. Y means y of root 2. So that equals 8. Okay. Here we need to do some integration. But these two functions given here are not integrable. We don't have any method to do the integration. So there must be some relation between these two functions. Only then there is a possibility of these two functions to get cancelled, right? Yes, let us find out the relation between these two functions, right? So this is the question given. So integral 1 to 2 log of x cube plus 1 dx. Okay, so base 2 plus another integration 1 to log 9. It is 2 to the power x minus 1 to the power 1 by 3 dx. So these are the two functions, right? Log x cube plus 1, 2 to the power x minus 1. Is there any relation between these two functions? This is in terms of log, but this is in terms of exponent. So there is a chance that these two functions are inverse functions of each other, right? So how will you find the inverse? Let us verify this. Okay, so let's find the inverse. Say log base 2 of x cube plus 1. So if you equate this to y, what do you get? X cube plus 1 is equal to 2 to the power y. So what is x value? We're getting 2 to the power y minus 1 to the power 1 by 3. So that is exactly what is given here, which means these two functions are inverse functions of each other. So there are many ways to solve this question, but let us use simple geometry, right? So let us draw this function. Okay, yes. Now 1 to 2. Okay, yes. Now let us do this. Let us draw this function. So 1, at 1 what is the value here? This function, at 1 what is the value? So this is 1 plus 1, 2. So log 2 base 2, so that is 1. At 1 this is 1. Okay, so let us draw this line which is y equal to x. Okay, at 1 it is 1, and then at this point 2, what is the value? So 2 cube is 8 plus 1 9. So log 9 base 2, some value here, so that is more than 2. So some value here. Maybe the graph is something like this. Okay, we don't know the exact shape, so maybe something like this. Now here this area we have to find. So this area is what we need to find. Okay, that is the integral. So integral means area. So this area is what we need to find. Okay, now plus we also need to find this area. What is 2 to the power x minus 1 to the power 1 by 3? This is the inverse function of this. So that means the graph will be symmetric about this. So if you draw symmetric about the line y equal to x, so that graph will be something like this. Okay, symmetric about this. So that area we have to find. Okay, this area we have to find separately, and this area we have to find separately. That sum is our required answer. So let us find this area, not separately. Now this shape, okay, now you take the reflection of this here. So this is the area. Suppose let me draw this by horizontal lines, right, like this. So that is the area given by the first expression. Now this is drawn using this vertical line. Okay, yes. But these two areas we have to find. But now what you do, you take the reflection of this on the line y equal to x. So we will get something like this. So that will become like this. So this area is the vertical line. So this area given by this vertical line, right? So that is same as this area, right? It's the same shape. So that means this area is what we need to find. So 1 here, and what is the value here? So that is log 9. We can find this area without using any integration, because what is this? It is a rectangle, but this portion is not there. So area of this rectangle minus area of this rectangle. So our required area is equal to, so area of this big rectangle. So that is the base is 2 multiplied by the height is log 9. So 2 multiplied by log 9. Okay, log 9 base 2. Okay, yes. Now minus this area. So that area is 1 multiplied by 1. So minus 1. So that's all. This is our required area. So that's all. So that is our required answer. But we have to find the approximate value of this. So this is log 9 square, so that is 81 to the base 2 minus 1. But log 81 is what? So 2 to the power 6 is 64, 2 to the power 7 is 128, but the 81 lies between 64 and 128. That means this whole value should lie between 6 and 7. So this is 6 point something. So this value is approximately 6 point something, okay, minus 1. So that means this value is 5 point something. So we want the integer part of this area, okay, so that is equal to 5. So that's all. So that is our required answer. If you observe that these two functions are inverse functions of each other, without any integration we will be able to do this, but we have to understand the geometry of this, a function and its inverse function. So their graphs, right, that is the reflection. One is a reflection of the other on the line y equal to x. You understand? Using this, instead of finding the area, this area, you take the reflection of that area, combining them we get a regular shape. So like a rectangle whose area we can easily find, right? So that's it, that's the answer. Here we have to find the solution of some equation which contains some log x and all. So let us simplify this equation first. X to the power something equal to 5 to the power minus 16. First of all, we will remove this exponent, right? X to the power something. So this is what is given. So x to the power, so 16 log x base 5 cube, okay, minus 68 log x to the base 5, okay. So this is the power of x, so that is given to be 5 to the power minus 16, okay. Now x to the power something equal to, so some constant value given, so then we have to remove this x exponent, right? So you can take log of base x, right? Log base x both the sides, that means this x will go to the other side, that will become log base x, right? So this exponent, so that becomes 16 multiplied by log x cube minus 68 log x base 5. So that equals, so this x, right, that goes to the other side, will become log base x of that value, right? So this is log base x of that value, right? 5 to the power minus 16. Okay, yes, now we have to simplify this. Okay, so let us take some variables, say t. So t is equal to log x to the base 5. So log x to the base 5. So this becomes 16 multiplied by, so this is t cube. So 16t cube minus 68t. So that equals, so here the base is x, right? We have to change the base actually. So this can be written as minus 16 times log 5 to the base x. Log 5 to the base x can be written as reciprocal 1 divided by log x to the base 5. So that means, so this is 16 divided by t, right, by change of base rule or whatever. So log x to the base 5, so that is a reciprocal of log 5 to the base x. So that's what this can be written as 1 by t, okay. So that's also, this will be an equation of the form, so 16 t to the power 4 minus 68 t square plus 16 equal to 0, okay. Now we can cancel some term, right? So I think we can cancel, say 4, so 4t to the power 4 minus, so this is yeah, so that is 2, sorry, so this is 1, 7 t square plus 4 equal to 0, okay, right. Now this is a quadratic equation, right? So quadratic equation t square, so we know how to solve it. You can either factorize it or you can use formula, whatever. So if you factorize it, you get 4t to the power 4 minus 16t square minus t square, so plus 4 equal to 0. So 4t square can be taken out, so it is t square minus 4 minus of t square minus 4 equal to 0. So we are getting the value of t square. So either t square is 4 or 4t square is 1, so t square is 1 by 4. So we get the value of t, so 2, minus 2, 1 by 2 and minus 1 by 2. So these are the values of t, okay. But we don't want the t value, we want the value of x, which means log x has values, so these many values, right, log x. So t is actually equal to log x to the base 5. So that means what is the value of x here? So 5 to the power 2, okay. So 5 square and 5 square and then 5 to the power minus 2 and 5 to the power 1 by 2 and 5 to the power minus 1 by 2. So that's all. So these are the possible values of x. Now if you want to find the product of all these values, so that's very simple. So product of all these values, see all these values get cancelled, right? This is 5 square, 1 by 5 square, so that gets cancelled. Here also 5 to the power half, 1 divided by the same value. So the product of all these values, so that is equal to 1. So that's all. So 1 is the answer to the question. See, we could have directly also written, see t, so we can find the sum of roots. Okay, directly we can write the sum of roots. So if you find the sum of roots, so that gives you the product of roots of this equation, right? So if you want to find log x, right, if you want to find the sum log x1 plus log x2 plus log x3, etc. So that is same as log of x1 plus x1 multiplied by x2 multiplied by x3 x3. So product of roots. So if you want to find the product of root, we can find the sum of roots of this equation, that is 0. Sum of roots is, so x to the power, right, 5 to the power 0, so that is 1, right? Directly also we could have written, but we want to make sure that all the roots are positive, right? Otherwise the product of roots of the given equation need not be the product of root of our equation, because not necessarily all the roots are positive, right? So we have to make sure that the roots are positive, real, all 4 roots are real and positive. Then if you use the sum of roots idea, then also we'll get it, but just not to get into all these things, directly you find all the roots. Okay, so because it is easy to solve, because it looks like a quadratic equation, easy to solve this, and we found all the roots. Once the roots are found, we can find the product, so we get the answer 1, right? So that's all. So 1 is the answer. Here we need to find some limit, but the expression given here contains different types of functions, like the exponential function and trigonometric function and some binomial expansion we have to do. But when you have an expression having different types of function in a limit, we use the series expansion, right? So let us use the exponential series, trigonometric series, so that all these different types of functions can be converted into one type, like a polynomial expression, right? So this is the question given. So we have to find this limit. So limit x tends to 0, e to the power x cube minus 1 minus x cube to the power 1 by 3 plus 1 minus x square to the power half minus 1 multiplied by sine x. Okay, so this is the numerator. So divided by the denominator is x sine square x, but x sine square x can be written as, so sine square x is there, so divide this by x square, so that we can use the formula sine x by x, which tends to 1. So sine x by x, that 1 tends to 1, so you divide by x square, you multiply by x square, so that will become x cube. So this term is gone, right, because that is 1, right? Separately we can find the limit, so that limit is 1, so we only are left with the x cube in the denominator. So let us simplify this. Let us use the exponential series and similarly trigonometric series, here also binomial expansion. So what is the exponential series? So e to the power x, so that is the formula, 1 plus x by 1 factorial, x square by 2 factorial, etc. Yes, let us use that series. So that is limit x tends to 0, so this is 1 plus, in place of x we have x cube, so x cube divided by 1 factorial. The next term is x to the power 6 divided by 2 factorial, but that is not required, because denominator maximum we have x cube, so higher powers can be, so we need not consider power x to the power 4, because anyway if you divide it you will still have x, so x tends to 0, that will be 0. The higher powers can be removed, right? So we only consider maximum x cube. Okay, that's it. Next, this is like a binomial expansion, but rational index, the power is not a natural number, so 1 minus x to the power n. So what is the expansion? 1 minus x to the power n, so that is the formula, 1 minus nx plus n minus 1 by 2 factorial, x square, right, etc. Right? Yes. Now it is 1 minus x to the power n. So what is the expansion here? So minus of 1 minus nx. Nx means 1 by 3 x cube. Again higher powers not required, so x cube, next power is 6, so we don't need that. So this one plus similarly same thing here also use the same idea, so it is 1 minus 1 by 2 x square. Next higher power is x to the power 4, which is not required, so minus 1 here. And sine x series, so sine x series, so we know sine x series, right? So x minus x cube divided by 3 factorial, etc. Yes, so x minus x cube divided by 3 factorial, which is 6. Again, so we only write only 2 terms. Okay, so this whole thing divided by x cube. Okay, so that's it. Now many terms get cancelled here, right? So this one, so this one, so that gets cancelled, and also here also 1. Yes, now simplify this x cube coefficient. So what is the coefficient of x cube? So this limit x tends to 0, x cube if you take out, so you get 1, and here plus 1 by 3 x cube, so plus 1 by 3, and here also x square multiplied by x, so we get x cube, so minus 1 by 2 x cube, so minus 1 by 2, and the next one is x to the power 5, which is not required, so this divided by x cube. So this x cube gets cancelled, and that's all, that is the answer. So 1 minus 1 by 2, 1 by 2 plus 1 by 3, so that is 5 by 6, right? So that is given to be beta. Beta is the value of the limit, so that we have found, so that is 5 by 6. So we need the value of 6 beta, so that has value 5. Okay, so that's it. So that is our required answer, right? Yes. here a matrix A is given and a condition satisfied by this matrix is also given. Using that we have to find the value of beta, right? So this is the condition given. So this matrix, say A to the power 7 minus beta minus 1, A to the power 6, and then minus beta A to the power 5. So this is a singular matrix. So that means the determinant value of this matrix, so that must be equal to 0, right? Singular matrix, so determinant is 0. Now we can simplify this. We can take out the common factor, so that is A to the power 5. You can take out, so we get A square minus of beta minus 1 A minus beta I, okay, not just beta I, because we can't subtract a scalar from a matrix, right? So beta I. So that's a, now this is like a quadratic expression, so that can be factorized. So let us factorize this quadratic expression. So A to the power 5, so it is like minus beta, so 1, so that is beta I, right? So the product is known, so we can simply write it as A minus I multiplied by A minus beta I. Okay, yes, is that right? So A square minus I, okay, this is plus I, so this is plus then, okay, so now it is right. So that equals 0. Now this is a product of three matrices whose determinant is 0. So that means we can separate it first of all, right? So this is determinant of A to the power 5, determinant of A plus I, and determinant of A minus beta I equal to 0. So the product of three numbers, right, the product of three scalars, right, that is 0. So one of them must be 0. Which one is 0? We don't know. So this or this or this, which one is 0? Let us see. So suppose this is 0. So determinant of A is 0. Possible? Let us check. Okay, let us find the determinant of this matrix. So this determinant of A is beta multiplied by, so minus 2 plus 2, so that is 0, and then plus 1 multiplied by 2 minus 3. Is it 0? So this becomes 0. This is minus 1. The determinant value is constant, that is minus 1. So this is not 0. So that means the first possibility is ruled out. So determinant of A is not 0. Now let us find determinant of A plus I. What is determinant of A plus I? With A, the matrix A, you add I. I means what? 1 0 0, right? 1 0 0 0 1 0 0 0 1. That matrix can be added and then find the determinant. So that is the determinant of, okay, so 1 is added. So beta plus 1, 0, and then 1, and then 2, and 1 plus 1, 2, minus 2. Just adding I, the identity matrix, with this matrix. Okay, so let's find the value of this determinant. So that equals, so beta plus 1, this is minus 2 plus 2, that is 0, plus 1 multiplied by, so this is 2 minus 6. Is it 0? No, it is minus 4. So that is also non-zero value. So no matter what the value of beta is, it is independent of beta. So this is never 0, these two determinants. The only possibility is that determinant of A minus beta is 0. So that means, so this implies, so determinant of A minus beta I must be equal to 0. So what is A minus beta I? So let's substitute that. So 0, 0, 1, and 2, 1 minus beta, and then minus 2, then 3, 1, minus 2, minus beta. Okay, yes. Now from the diagonal elements we subtract beta. That's all. That's the meaning of A minus beta I. So find the value of the determinant. That's very easy to find. 1 multiplied by this product. So this must be equal to 0, right? Yes, that's all. So 1 multiplied by, so 2 minus 3 plus 3 beta. So that equals 0. So that gives you the value of beta. So beta is 3 beta equals 1. So beta is 1 by 3. So beta is 1 divided by 3. That's all. So what we need to find is the value of 9 beta. So 9 if you multiply, so 9 times beta, so that equals 3. So that's all. So that is our required answer, right? So that's all. So it's very simple. See, first of all, so we can easily factorize it. So that's what is important, right? If it is not factorizable, maybe we wouldn't have done by this method. So you factorize it. So product of these values is 0. So one of them must be 0. Which one is 0? So that's what matters. Which one is 0? These two are not 0. Not possible. So only possibility is that this determinant is 0. So find the value of the determinant, equate to 0. So that's all. That gives you the value of beta. That's all. Yes. Here a hyperbola equation is given and a lot of things related to the hyperbola is given. See, S and S1 are the foci of the hyperbola. This angle SPS1 is given as alpha, where P is some point on the hyperbola, right? Yes. Now SPS1, so that angle is alpha. We need to use some properties of the hyperbola here. Now you draw a tangent at the point P. That tangent bisects this angle SPS1, right? So this angle SPS1, that is alpha, is bisected by the tangent. So that is the property of the hyperbola. So that means that angle is half of that, right? Alpha by 2. So that is one thing given in the question. Next one, you draw a line through the point S parallel to that tangent, right? So that line is taken as SP1, right? So that line, now from the point P, we draw a perpendicular to this line which meets at the point, say, M. So that length is also given, that is delta, right? Delta is the length of perpendicular from P to this line SP1. Okay, done. And also from S1 to P, that distance is given as beta. Okay, yes. Now what is the distance? Now we draw a perpendicular from the point S1 to that tangent. So suppose it meets at the point N. So that S1N is the perpendicular line, right, to the tangent. Okay. Now what is the perpendicular distance from the point S to that tangent? That is same as delta, right? So if you drop a perpendicular from S to that tangent, so that will be same as delta, right? Yes. Now we have to use another property of this ellipse or hyperbola, right? So both have the same property. See, from the foci S and S1, you draw perpendicular to any tangent. Suppose this perpendicular, right, SP, SQ. So this product SP multiplied by SQ is always equal to B square, right, the square of the semi-minor axis. So this is the property of the hyperbola and also ellipse, right? So that property we are going to use. Okay, yes. Now let us use that property. So what is the distance from the focus to the tangent, right? S, from the point S to that tangent. What is the distance? That is delta. So that delta multiplied by, similarly from the other focus. So the other focus is S1, S1N, right? Delta multiplied by S1N. So this is the product of distances, perpendiculars from the foci to any tangent. So particularly this tangent at the point P. So this product is equal to B square. So this is the property that we are using here. Okay, here delta multiplied by S1N is equal to B square. Okay, but delta is given in the question, so we can leave it as it is, multiplied by, but what is Sn? So that is a right angle triangle, right? SNP is a right angle triangle. So then we can use some sine or cos, right, trigonometric ratio. So sine alpha by 2 you take. What is sine alpha by 2? That is opposite side, S1N divided by the hypotenuse, that is beta. So S1N divided by beta, so that is sine alpha by 2, right? Yes. Now that means what is S1N? So S1N is beta sine alpha by 2. Okay, so just using trigonometric ratio. So that is equal to this B square. But B square is what? That is given in the question, the equation of hyperbola. So that is x square by a square minus y square by b square. So b square is 64. So that's it. So delta beta sine alpha by 2 divided by 9. That's what we need to find. So this gives delta beta sine alpha by 2 divided by 9. So that has value 64 divided by 9. So that's all. So this is the required answer, right? But we want to find its integer value, right? So the integer part of 64 divided by 9. So I think 64 by 9 is 7 point something, right? So 7 point something. So the integer part is 7. So that's all. So that is the required answer. So this particular property is important. So that's what we've used here, right? The product of perpendiculars from the foci to any tangent. So that is B square, right? That is common to both ellipse and hyperbola. So that's what we've used here to get this answer. Okay, yeah. Here we need to find the area of the region given by these two functions, right? So obviously what do we have to do? We have to draw the curves, right? Let us draw them one by one. Yes, the first one is x square plus 5 by 12. So this is the first function, x square plus 5 by 12. So y equal to x square is a standard parabola, right? So passing through origin, but 5 by 12 is added, so which means it is lifted up by 5 by 12, right? Yes, this is the parabola. Okay, yes. So this is 5 by 12. Next one is some modulus function. Modulus of x curve, we know, modulus of x graph is like this. And minus modulus of x, minus of that is here, upside down, okay? But 1 is added, that means it is lifted up by 1 unit. So the graph will be something like this. So this is the curve, okay? 1 minus 4 modulus of x divided by 3. Okay, now we have to find the minimum of the two functions, right? So minimum. So minimum means what? Among the two, we have to compare these two curves. Whichever lies the lowest, so that is the minimum. So that means from this point here. Because comparing these two curves, this is the lowest, right? So that is minimum. So one that lies below the other, so that is the minimum function. But both these functions, if you observe, they are even functions. So this graph is symmetric about y-axis. That means you find area, this part, and multiply by 2. So we get the total area, right? Let us find the area of this part only. Yes. Now this point is known where that line intersects x-axis. Put y equal to 0, which means so that is 2 by 3, right? So yeah. So that is 3 by 4, sorry. So 1 minus 4x by 3. So that is 0. So x equal to 3 by 4. So 3 by 4 is the maximum value. And 0 here. Now what do we do? So you can find the area in two parts, right? So here up to this point, so that is the area below that parabola. From this point to this point, so that is area below that straight line. Okay, yes. But what is this point? So we have to find that point, right? To find the point of intersection of the two curves, so we have to solve the two functions. Yes, let us solve them. So x square plus 5 by 12. So that is the first function. That equals 2 multiplied by 1 minus 4x divided by 3. I am writing only 4x, not modulus of x, because it is only positive, right? Positive region. So x. So now we simplify this, you get the value of x. Okay, so let us simplify this. So this is x square plus 5 by 12, okay, equal to 2 minus 8x divided by 3. Okay, so this is, okay, x square plus 8x by 3. Yeah, so that minus, so this is 24 minus, so minus 19 divided by 12. Okay, so that equal to 0. So this is like a quadratic equation. We have to solve this to get the value of x, right? So what are the values of x that satisfy this equation? So multiply this by 12. Okay, so 12x square plus 32x minus 19 equal to 0. Okay, yes, solve this to get the value of x, or if it is possible to guess the value, so it is 3 by 4 right here. So this value is less than 3 by 4, maybe 1 by 2, 1 by 3, something like that. Okay, so 1 by 2, does it satisfy 1 by 2? Okay, so let us check. See, instead of solving it, I am just trying to guess the value. So 1 by 2, if we substitute 1 by 4, so that is 3, and 3 plus 16, 3 plus 16 is 19, minus 19, 0. So that means, so 1 by 2 is the answer. There is one more root, but that is not required. The other root is negative, but we are only calculating the positive root. So x equal to 1 by 2, so that is the value. Okay, so 0 to 1 by 2, it is area below that parabola. 1 by 2 to 3 by 4, it is area below that modulus function. Okay, so that means our required area is 0 to 1 by 2. So that parabola, which is x square plus 5 by 12 dx. Okay, plus the next area. But for the next area, we don't need to use the integration because it is a triangle area, right? So triangle, we can use the direct formula, half base height is a right angle triangle. So it is half the base length. The base length is 3 by 4 minus 1 by 2. So that is 1 by 4 multiplied by the height of the triangle. So height is when x is 1 by 2. If you substitute x 1 by 2, whatever we get, so that is the height. Okay, y coordinate. So if x is 1 by 2, what is the value of that? So it is 1 by 4 plus 5 by 12. So that is 3 plus 5, 8 by 12. So that is 2 by 3. So 2 by 3 is the height. So that means this point is 1 by 2, 2 by 3. That's it. So this will give you our required answer. So let us simplify this. So this equals x cube divided by 3. So x cube is what? 1 by 8 divided by 3 plus 5 by 12. So 5 by 24. Okay. Plus this is 1 divided by 12. Okay. So that's all. So let's simplify this. So we'll get our required answer. This is 24 if you take the common value. So that is 1 plus 5 plus 2. So this equals, so 8 by 24. So 1 divided by 3. So this is the value of the area, right? So area. So that is given as some alpha or something. Okay, alpha. So we want 9 alpha value. So 9 alpha equal to multiply this by 9. So that is 9 by 3, which is 3. That's all. So that is our required answer. You understand? See, it's a very simple question. Okay, so we have to draw the curve. We will get an idea of what area to be found. So that's all. So that gives you the answer directly. So 9 alpha equals 3. Okay. This is not the answer because we only found half the area. We have to multiply this area by 2 because the function is an even function. It is symmetric about y-axis. So our answer should be multiplied by 2. So that means 6 is the answer. Here a quadrilateral PQRS is given and some angles and the lengths of the sides are given. We have to find these values, right? Alpha and beta, right? So let us draw this quadrilateral first. See here we have a quadrilateral PQRS, right? So that means it is something like this, PQRS. Okay, so but this length, okay, this angle is given. So PQR, so that angle is given as 70 degree. Okay, similarly angle R, so that is also 70, so it is like this. And so PQRS, okay, so this is the quadrilateral. So what are the other values given? So the angle PRS, so that is given as 40, so this angle is given 40. And similarly another angle is given, angle PQS, so that is 15, so this angle is 15. Okay, and the lengths of the sides are given, so this length PQ is alpha and this PS length is beta, and then QR length is 1. So these are the values given. Okay, yes, now all the 4 sides are known? No, only 3 sides are known, alpha, beta and 1. What is this length? Is it possible to find this length? What is this angle? So that angle is 70 minus 15, that is 55. Okay, this angle is 55 and this angle is 70. 70 plus 55 in this triangle, so 70 plus 55, so that 180 minus that value, so that is 180 minus 70, 110 minus 55, that is also 55. This angle is 55 degrees, this angle is also 55 degrees, that means it is isosceles triangle, so this length is 1. Okay, and this angle RPS is also given, so that is theta. So many values are given, right? Yes, now we have to use obviously sine rule, right, because we need to relate the side and angles of the triangle. Let us use sine rule. So let us use, we want to find alpha, so let us use this triangle. So for this triangle, so in triangle PQR, okay, PQR, in triangle PQR, so we use sine rule. So what is sine rule? Alpha divided by sine of this angle, so alpha divided by sine of that angle. That angle is 70 minus 40, that is 30 degrees. So that equals this side 1 divided by sine of the opposite angle, that is this one. Yes, 1 divided by sine of, so this angle. So what is the opposite angle? This angle, right? So that angle we have to find. So what is that angle? This angle is 70 in that triangle. So this angle is 30 degrees, so that means 100. So 180 minus 100, so that is 80 degrees. So this is the angle alpha, right, the value alpha. So this gives you alpha, so that equals sine 30 is 1 by 2, so that means 1 divided by 2 sine 80 degrees. So this is alpha. Similarly we have to find beta. So to find beta we have to consider this triangle, because that triangle contains beta. So let us find triangle PRS now. In that triangle, beta divided by sine of the opposite angle. So what is the opposite angle here? So that is 40 degrees. That equals, so this length 1 divided by sine of the opposite angle, so that is theta, so sine theta. So that gives you the value of beta, so that is sine 40 divided by sine theta. Okay, so that's all. We got the value of alpha and beta. Now we have to find alpha beta, right? The product we have to 4 alpha beta. So let us find alpha beta first. So alpha beta equals, so this product we have to find. So that is 1 divided by sine 40 divided by 2 sine 80. But sine 80 can be written as again 2 sine 40 cos 40. 2 sine 40 cos 40 multiplied by this sine theta is there. Okay, yes, now 1 sine 40, that gets cancelled. Now what is left? Now cross multiply alpha beta, if you multiply sine theta, and you can even multiply that 4. So 4 alpha beta sine theta, that equals 1 divided by cos 40. So that is same as secant 40 degrees. So that is the value of 4 alpha beta sine theta. So we don't know the exact value of secant 40, right? But you should find the range of the possible values of this secant 40. But 40 degree we don't know, but 45 degree we know, right? And similarly 30 degrees, this 40 lies between 45 and 30 degrees, right? Yes. So 40 degrees, so that lies between 45 degrees and 30 degrees. Now secant 40, so which means secant 30, so that is 2 by root 3 less than, so 40, secant 40, so that is less than secant 45 degree, that is root 2. So this required secant 40 degrees lies between these values, right? Approximately we will find, so 2 divided by root 3, right? So 2 divided by 1.7 something, so this is approximately 1.2, we don't know the exact value, 1.2 something. So this is less than 1.4. So our required value secant 40 are this whole thing, 4 alpha beta sine theta lies between something like 1.2 and 1.4. Now tell me which of these options satisfy this condition. This values between 1.2 and 1.4 lies in that interval 0 to root 2 and also 1 comma 2, right? So that is the interval in which it lies. The other two options do not satisfy, right? Other two options do not contain values in this interval. So the answer must be 0 to root 2 and also 1 comma 2. So that must be the answer. Okay, yes. here the value of alpha is given as a series, right? We have to find the sum of this series to get the value of alpha, and then this alpha is used in the function g of x. So let us first find the value of alpha by simplifying, right? So let us find the value of this sum of the series, right? Yes. Now the series given here is this one. So sum of so k from 1 to infinity sine to the power 2k pi by 6. So that is very simple, right? Sine pi by 6. So sine 30 is 1 by 2. 1 by 2 to the power 2k, or 1 by 4 to the power k. So this value is summation k from 1 to infinity 1 by 4 to the power k. So this is a geometric series, right? So this is a geometric progression with the first term 1 by 4 and the common ratio is also 1 by 4, right? 1 by 4 plus 1 by 4 square, cube, etc. So sum of infinite GP. So that is A. A is 1 by 4 divided by 1 minus R. R is also 1 by 4. So this gives you the value 1 by 3. So that is the value of alpha. Once alpha is found, the function g of x is known now. So g of x equals 2 to the power alpha x, which means 1 by 3x plus 2 to the power alpha again. So 1 by 3 multiplied by 1 minus x. So that is the function g of x. We have to find its minimum and maximum values. So to find minimum maximum, we can use the method of arithmetic mean, geometric mean, because this is 2 to the power x by 3. Here 2 to the power minus x by 3. They are like reciprocals of each other. So we can use arithmetic mean, geometric mean relation. But instead we will use the derivative method only, because anyway we have to find both minimum and maximum. Arithmetic mean, geometric mean will give you only the minimum value of this, right? We need to find the maximum value also. So let us use the derivative method itself. So any one method will do, okay, no problem. So 2 to the power, a to the power x derivative is what? A to the power x log a. So 2 to the power 1 by 3x and 1 by 3 log 2. So that we can multiply later. So here minus 2 to the power 1 by 3, 1 minus x, right? Minus because of this minus x. And then multiply by, so this is 1 by 3 log 2. Okay, so that is the derivative. We have to equate the derivative to 0. So let us equate the derivative to 0. These are all constants. So this gives you the value of x. So 1 by 3x equal to 1 by 3 minus 1 by 3x. Okay, so that's all we have to solve it. So 2x by 3 is equal to 1 by 3. That gives you the value of x 1 by 2. So that's also, that is the value of x. Okay, so x is found at which the function may be minimum or maximum. Is it minimum or maximum? For that we have to find the second derivative, and positive or negative accordingly we can find. Now we don't do that. We don't find the second derivative test, or we don't use the first derivative test either. So instead, see here an interval is given, right? Closed interval. To find the minimum or maximum value in a closed interval, so we don't use the first derivative test or second derivative test, simply by comparing the values, right? Let us find the value of the function at this point and the value of the function at the end points, compare them, that's all. So what is g of 1 by 2? So just substitute 1 by 2 here. So this is g of x. G of 1 by 2 is 2 to the power 1 by 6 plus here also 1 minus 1 by 2 is 1 by 2. So 2 to the power 1 by 6. 2 times 2 to the power 1 by 6. So 2 to the power 1 plus 1 by 6 is 7 by 6. So this is the one of the values, right? So we don't know its minimum or maximum. So now let us find the end value. So g of 0, okay, and also g of 1. Now among these values, whichever is maximum, that is the maximum value of the function. Similarly minimum value, okay. So g of 0, so substitute 0 here. So 2 to the power 0, so that is 2 to the power 0 is 1, and here also, so 2 to the power 0 plus this is 2 to the power, so x is 0, so that means 2 to the power 1 by 3. That means 1 plus 2 to the power 1 by 3. Now substitute 1. So if we substitute 1, 2 power 1 by 3 plus 2 to the power 0. So that is same value, right? So 1 plus 2 to the power 1 by 3. Now we've got these two are same values, right? So among these two values, so whichever is maximum, that is the maximum value of the function. Okay, you tell me which is maximum. 2 to the power 1 by 3, 1 plus this thing. So which is maximum value among these two? So that is 2 times. So 1 plus 2 to the power 1 by 3 is the maximum value, right? Yes. So this is the value bigger than this, right? So we can compare and find, right? So this is maximum value, but maximum is attained at 2 points, right? So this is maximum. Maximum. So the minimum is at only 1 point, 1 by 2. So this is the minimum value of the function at only 1 point. But maximum value is 1 plus 2 to the power 1 by 3. But that is attained at 2 points, right? 0 and 1. So this must be the answer. This is one hell of a question. If anyone has done this question in the first attempt itself, is a real genius. I'm not 1 by the way. So let's solve this question. Yes, see, this is given that, so z bar square, okay, so conjugate of z square and 1 by z square. So that is, okay, so the real part and imaginary part of this number is an integer, okay. That means suppose you take this as some u plus iv, both u and v are integers, okay. Yes, now so using that we have to find the possible values of modulus of z, right. So what we do is, let us take the modulus of this, right, because we have to find the modulus. So you take the modulus, so z square, so that equals modulus of u plus ib, okay, square it. See, we have the formula, right, so it is modulus of z1 plus z2 square, so that is what, mod z1 square plus mod z2 square plus 2 times real part of z1 z2 bar, right. So that means this becomes modulus of this square, no need of conjugate inside the modulus, right. So plus, so 1 by, again this is modulus of z square plus 2 times real part of this multiplied by this conjugate, or this multiplied by this conjugate, any one doesn't matter, real part of, I'm writing this one, so 1 by z square multiplied by the conjugate of this, so that is also z square, so that equals, so right hand side, that is simple, modulus of that u square plus v square, okay. Yes, now let's simplify this. So modulus of z square plus 1 by modulus of z square, this is plus 2, okay, because this is 1, okay, 1 by z square, that gets cancelled, so 2 equal to that one, so we can take it to the other side, u square plus v square minus 2, okay. Now what do you do, we have to square it again. Why do you want to square this? Because we want modulus of z to the power 4. See, if you look at all the options contain something to the power 1 by 4, that means modulus of z to the power 4 is what we need to find, then only power 1 by 4 will get, so we want power 4, so let us square this. So what is square of this? Modulus of z to the power 4 plus 1 by modulus of z to the power 4 plus 2 times ab, so that is 2. So this is like a plus b the whole square, not complex number, all these are real numbers. We are just using a plus b the whole square formula, not the formula of this type. So plus 2 equal to this square, okay, so that is u square plus v square minus 2 square, okay. Yes, now what you do, you can take it to the other side, but so this, okay, u square plus v square minus 2, so that is anyway an integer, so for the time being we will take the whole thing as some number, say like k. So this is modulus of z to the power 4 plus 1 by modulus of z to the power 4, so that equals, I'm taking this as k, so k minus 2, okay, so where k is an integer, okay. Now let us simplify this. This is modulus of z to the power 4, if you bring it to this side, so minus k minus 2 modulus of z to the power 4, so this is power 8, right, and then plus 1 equal to 0. Isn't it like a quadratic equation in mod z to the power 4? Quadratic equation modulus z to the power 4. So solve this, we'll get modulus of z to the power 4. So that equals modulus of z to the power 4 equals, so k minus 2 minus v plus or minus, so that formula we are using. So square root of this b square. So k minus 2 square minus 4ac. So minus 4 divided by 2. So this is the value of modulus of z to the power 4. Now we want to find modulus of z. So this whole thing to the power 1 by 4. So that is the value of modulus of z. But that is in terms of k. But k can be anything, right? So it is of the form u square plus v square minus 2 the whole square. So it will have infinite possibilities, right? So that means it is not a unique value. Modulus of z is not just one value. It may have infinite possibilities. But among the given options, whichever satisfies this condition, right? It is of this form, then that can be our answer, right? See which form? K minus 2, whatever is this value here, that value squared minus 4. So if it is of that form, so that can be our answer. So k minus 2, so this squared minus 4, that must be the value inside the square root, okay. Let us take the options one by one. See, for example, first option, 43 square. So the option A, so that is 43 square minus 4, okay. What is 43 square? So 43 square can be found, so you can find that, right? So 1849. So minus 4, so square root of that we are finding, okay. Yes, so this is square root of 1845. Now we can take out the common factor, which is it can be divisible by 9, right? So 9 if you take out 3, it will become 3 square root of 9 if you take out, it is 2045, so that is 5. So 3 root 205, if it is of that form, yes, so 3 square root of 205, so it is of this form, that means, so the first one can be the answer. Now let us take the second one, so B, so that is 7 plus root 33, so square root of 7 square minus 4, is it equal to 33? Let us check. So this is square root of 45, Okay, so this is root 45, but that is not equal to what is given, right? That is not equal to 33. So that means that is not our answer. So the second option is not in this form. Okay, now similarly we can verify the other options also. So that is 7 plus root 65. So let us find 7 square minus 4. So is that equal to, sorry, 9 square minus 4. So 9 square minus 4 is root 81 minus 4, so that is 77. So that is not equal to what is given, that is 65. So that is not our answer. Similarly, so the next one, so that is 7 plus root 13. Okay, which means again root 7 square minus 4. So that is equal to root 45. So that is not what is given here. So that is 13. It is not 13. So these three options B, C and D are not of this form. So only one option which is of this form. So that is our required answer. Okay. Here we have a bigger circle around which we have some smaller circles. Now the radii of the circles are capital R and small r. We have to find the relation between these two values, right? Capital R and small r for different values of n, right? So let us now consider only one circle, right? So here this is the bigger circle and one circle touches this circle. Okay. Now so you join this, the centers, and yeah, so this one. Now this is perpendicular, right? So because this is a tangent, so that is perpendicular to the radii, right? The radius vector, right? Yes. Now what is this angle? So that angle we have to find. Okay, so this total angle is 360 degree, right? 2 pi, but this angle is, right, so there are n angles, right? N circles are there, so that means it is 2 pi divided by n. So its total angle is 2 pi divided by n. So we are even taking, not even taking the total angle, only half of that. So that is pi divided by n, right? So half of that, this total angle subtended by this circle, that is 2 pi by n. So this is half of that, pi by n. Okay, now what is this length? So that is the radius of the bigger circle, radius of the smaller circle, and this is the radius of the circle, small r, right? So these are the things known. So it is very simple geometry, right? Basic trigonometry. So we can take sine theta, right? Sine of this angle, so that equal to r divided by, so sine of pi by n equals this opposite side, which is r, divided by this hypotenuse, which is capital R plus r, right? So if you cross multiply, so r by r plus 1 is equal to 1 divided by sine pi by n. Okay, so let's simplify. So capital R, that equals, so if you cross multiply, minus 1, r multiplied by cosecant, right? So 1 by sine, so cosecant pi by n minus 1. That's all. So that is the relation between this these two circles, right? Capital R and small r. That's all. Now for different values of n, right? So you have to substitute the value of n, say 4, 5, 8, 12, right? For different values of n, what is the relation? So that's what we have to find. Now let us do it one by one. Now if n is 4, then what is capital R? So that is r multiplied by, this is cosecant pi by n. So pi by n, but n is 4. So pi by 4, right? Cosecant 45, that is root 2. So root 2 minus 1, which means capital R is small r multiplied by root 2 minus 1. But what is given here is capital R is greater than that. Okay, that is not true. Okay, that means, so first option is not true. So now let us calculate the next one. So n equal to 5. So if n is 5, so r is equal to r multiplied by cosecant pi by 5. So what is pi by 5? So that is approximately, so pi by 5, right? So 180 by 5. So that is 36 degree. So cosecant 36 degrees minus 1. So let's find this value, cosecant 36. We don't know the value of cosecant 36. So but you compare this with the known value, right? Like 30 degrees, right? So 36 is closer to 30. So 36 degrees. So that is greater than 30 degrees. Okay. Now cosecant 36 is cosecant 36 degrees. So that is less than cosecant 30. See, inequality reverses because cosecant x is a decreasing function in the first quadrant, right? So that means the inequality reverses. From the graph we can understand it's a decreasing function. So inequality reverses. Cosecant 36 is less than cosecant 30, but cosecant 30 value we know 2, right? Yes. So that means 2 minus 1. So this r is actually less than, okay, because this value is less than 2. So r is less than small r multiplied by 2 minus 1. So capital R is less than small r. So this is the relation. But what is given here is capital R is greater than small r. So that is not correct. Okay. So now we have to find the next case where the value of n is given to be 8. So n is 8. So when n is 8, that case what do you get? So capital R equals, so here capital R equal to small r multiplied by cosecant pi by 8. Okay. Cosecant pi by 8. So yeah, cosecant pi by 8 minus 1. So pi by 8 is what? So half of 45 degree. So less than 45 degree only. So pi by 8 here is less than pi by 4. So that means cosecant pi by 8 is, again inequality changes, greater than cosecant pi by 4, which is root 2. So this value of r is greater than small r multiplied by, this is root 2 minus 1. Is that okay? So capital R is greater than small r multiplied by root 2 minus 1. So that is what is given. So no problem with that. So now n is equal to 12. So when n is 12, so 12 means what? So that is pi by 12. So pi by 12 is pi by 6 by 2. So that means 15 degrees, right? So r equals small r cosecant 15 degrees minus 1. So to find 15 degrees, right, so we have to use the formula, right, 45 minus 30 or 60 minus 45. So you have to write it as, okay, let me write it as 1 divided by, so this is sine 15 degrees, so we can write it as sine 60 minus 45 or 45 minus 30, whatever. So that equals r. So what is sine a minus b formula? Sine a cos b minus cos a sine b. So sine 60 root 3 by 2 minus cos 60. So that is 1 by 2. Alright, so we know how to use the formula. So sine a minus b formula we have to use. So if you use the formula, so we'll get, so root 3 minus 1 divided by 2 root 2, right? So 2 root 2 I'm writing here. So 2 root 2 minus 1. So that's it. Now what do you have to do? To simplify this, you rationalize it. Root 2 plus 1, root 2 plus 1. So root 3 plus 1. So if you multiply by root 3 plus 1, root 3 minus 1, denominator will become 2. 3 minus 1, 2. That 2 gets cancelled. So this is equal to, so r multiplied by, so this is what? So 2 gets cancelled, root 2 multiplied by root 3 plus 1 minus 1. Okay, yes. So that's it. This is the relation. Is that what is given? Now, great. Okay, so that 1 is not there. So that means this small r, so minus 1 is there. So that means this value, right, the whole value is less than this value, right, because we are subtracting minus 1. So r is less than small r multiplied by root 2 times root 3 plus 1. Okay, so we're removing that minus 1. That means this value becomes bigger. So r is less than small r root 2 root 3 plus 1. Is that what is given? Yes. So that is the correct answer. So that's all. So this is one answer. So this is also one of the options given. So that is the answer. Here some vectors are given a, b and c, and some conditions satisfied by these vectors are given. Using that we have to find the relation between these a, b, c, right? So let us do it one by one. First some matrix multiplication is given. Let us multiply these two matrices and see what happens. Okay, so 0 multiplied by 1. So if you multiply the matrices, we get 0 minus c2b2 minus c3b2 plus c2b3. Okay, and the next element c3 multiplied by 1. So c3 minus c1b2. C3 minus C1 B3, and the next element, so minus C2 plus C1 B2, minus C2 plus C1 B2. Okay, so this is the matrix multiplication, and the next right hand side, that is separated into two parts, 3 1 minus 1. So that is one matrix added with the next one, so minus C1 minus C2 minus C3. Okay, so this is what is the matrix multiplication. Okay, now it's important to observe what this is. This C3b2 plus C2b3, and similarly this one. So that is nothing but this cross product, right? That is the cross product of B and C, right? So what is B cross C? So let us find B cross C. So B cross C is this I cap, J cap, K cap, and B vector is 1, B2, B3, and then C1, C2, C3. So what is this cross product? So that is B2, C3, B2 C3 minus C2 B3 I cap. Okay, so that is the first component, and next plus J cap multiplied by, so B3 C1, B3 C1 and minus C3. Okay, plus K cap multiplied by, so this is C2 minus C1 B2. If you observe, this is what is given here, right? So B2 C3, so B2 C3, negative of that, so B2 C3 plus C2 B3. Okay, similarly, so C3, so C3 minus this one. So whatever we got here, that is the cross product or negative of the cross product of B cross C. So that means it is C cross B. So this is C cross B. So that is one observation which is important for this question. C cross B is what is given as this matrix multiplication. So C cross B, so that equals the right hand side. What is this matrix? 3 1 minus 1. So that is the vector A. Right, so vector A is only 3 I cap plus J cap minus K cap. So that is A vector. That is minus C1 minus C2 minus C3. That is C vector. So that means it is minus C vector. So this is one relation that is given in a different way. Okay, yes, so this is given. Now what we do? Now you multiply this. Okay, take dot product with the A or C. Right, Okay, let us take dot product with the C or B, right? Take dot product with the B, for example. First, C cross B dot B. So if you take dot product with B, so that will become, so A dot B, both the sides we take dot product with the B. This is 0, right? Because it's a triple product, right? C, B, B, right? Two vectors are equal. So this becomes 0. So that means right hand side is also 0. So this gives you the relation. So A dot B equals C dot B. But we know that A dot B is 0. That is given in the question itself. So A dot B is 0 and so is C dot B then. So C dot B is 0. So this is one relation. Okay, C dot B is 0. Okay, now what you do? Take the same thing, take dot product with the, this time C. Okay, take dot product with C. So we'll get C cross B dot C. So that equals, if you take dot product with C, that is A dot C minus C dot C, that is C square or modulus of C square. Okay, yes. So now what is this? Again 0. So this is also 0 because again two vectors are equal. So 0. So that means right hand side is also 0. So A dot C is equal to C square. Okay, now what is A dot C? So that is AC cos theta. Okay, angle between A and C, that is theta. So C square. So if you cancel C square, we get C equal to A cos theta. Okay, but A cos theta is less than or equal to A, right? Because cos theta is less than or equal to 1. So A cos theta is less than equal to A. Okay, yes. Now, but A is what? That is the magnitude of A vector. So what is the A vector is given in the question itself. So what is magnitude of A? So that is square root of 9 plus 1 plus 1. So C is less than equal to square root of, so magnitude of A. So that is 9 plus 1 plus 1. Yes. So 3, 1 minus 1. Then the value of C, that means the magnitude of C vector. So that is known. So magnitude of C vector, that is less than equal to root, this is 11, right? So magnitude of C is less than equal to root 11. So that is one conclusion, right? Yes, yes. Now this is found. Now we also have to check whether this A dot C is 0 or not. That is also one of the options. Is A dot C 0 or is it possible that A dot C is 0? If A dot C is 0, then C is also 0, right? The vector C is 0 then. Then this is 0 then. Then A minus C is 0, so A is equal to C vector. But C is already 0, A is also 0. But A is not a 0 vector, right? 3I kept something. So this is not a 0 vector. It's not possible that A dot C is 0. So that is not possible. So the next option here is B dot C is 0. That we have already concluded, right? So B dot C is 0. Now we have to check the magnitude of the vector B, right? So to find the magnitude of the vector B, so we use the condition that is given in the question. A dot B is 0. That is given. So let us check what happens when A dot B is 0. So if A dot B is 0, so let us take the dot product. So what is A dot B? So that is 3, 1 minus 1, 1, 1, 1 B2, etc. So 3 plus B2 minus B3, so that equals 0. This gives you some value, B2 minus B3 equal to say minus 3. So this is one relation we have. Okay, we can use it to find magnitude of B. So what is magnitude of B? Magnitude of B equals square root of 1 plus B2 square plus B3 square, right? So that's just the magnitude. Now, but we know only the value of B2 minus B3. So we can write this B2 square plus B3 square as B2 minus B3 the whole square, correct? B2 minus B3 the whole square plus 2AB, right? That is plus 2B2 B3. Something like A square plus B square, that is A minus B square plus 2AB. Okay, but B2 minus B3 is known, that is minus 3. So that can be substituted here. So this equals square root of 1 plus, this is minus 3 square. So that is 9. And this value is, okay, 2B2 B3. But B2 B3 is always greater than 0. So this value is positive. So this magnitude of B from this can be written as, so this value is root 9 plus 1, so that is root 10, but this value is greater than 0, which means the whole value is greater than root 10, correct? Because this is root 10 plus some positive value, so that is always greater than 0, right? Greater than 0. So root of 10 plus 0, that means it's greater than root 10. So B, magnitude of B is greater than root 10. So that is also one option, right? So that means, so magnitude of B is greater than root 10, and also magnitude of C is less than equal to root 11, and then this B dot C is also 0. So this is the answer. Here we are given a simple differential equation. Let's solve this equation, right? So this is a linear differential equation because it is of the form dy by dx plus p multiplied by y equal to some q, a function of x, right? Yes. So this is of the form dy by dx plus 12y. so p is 12, so that equals q, which is cos pi x divided by 12. So this is a linear differential equation, so we can find the integrating factor. So the integrating factor equals e to the power integral p dx, so 12 dx. So that means e to the power 12x. Now what is the solution of this? Y multiplied by the integrating factor, so y multiplied by e to the power 12x, so that equals integration of this q, right, that is cos pi x by 12 multiplied by this one, so e to the power 12x cos pi x by 12. So that's all. So this integration we have to do, that's it. So let's do this integration. So how will you do this integration? See, it is a formula, you have to use integration by parts, right? But we don't do that, right? Because 2 times we have to do integration by parts. But if you remember this as a formula, it is better, right? So if you remember e to the power ax cos bx, so that is the formula, e to the power ax cos bx as the formula, e to the power ax divided by a square plus b square multiplied by a cos bx plus b sin bx. So that is the formula. If you remember this, so directly we can use it. So that equals, so e to the power ax 12x divided by a square plus b square, so 12 square plus b square, which is pi square by 12 square multiplied by a cos x, so a cos bx, so 12 cos pi x by 12 plus b is pi by 12 sine pi x divided by 12. Okay, so that is the integration of this thing. Okay, so now we've got the relation y e to the power 12x. Okay, or we can find y also. So y is equal to e, so we can divide by this e to the power 12x, right? So if you divide this e to the power 12x, so this is simply 1 divided by, so 12 square plus pi square by 12 square multiplied by 12 cos pi x by 12 plus pi by 12 sine pi x by 12 plus c e to the power minus 12x. Okay, because we are dividing by e to the power 12x. Okay, so now we got the relation, but this c value can also be found. Okay, so to find the value of c, we have to use the relation given y of 0 is 1. So which means when you substitute x is 0, so y must also be 0. So x is 0, y is also 0. So 0 equal to, so this value, so sine 0 0, so cos 0 1, which means 12 divided by this value. So that will give you the value of c, right? So that is c equal to minus of 12 divided by this value, right? So just substitute the value. So that means our function is y equal to the same thing, 1 divided by 12 square plus pi square by 12 square multiplied by, so this one 12 cos pi x divided by 12 plus pi by 12 sine pi x divided by 12. This c value is, this value goes to this side, so minus of this, okay, minus 12 divided by 12 square plus pi square by 12 square multiplied by e to the power minus 12x. So we got the function y in terms of x, right? So this is the function y. Okay, now we have to see which of these options are satisfied here. Is it an increasing or decreasing function or a periodic function? It is not an increasing or decreasing function because this is a periodic function. This goes up and down, right? And also this is not a periodic function. This is a periodic function, but this is exponential function, so that is not periodic function. So it is not an increasing or decreasing function, nor is it a periodic function. But does it intersect x-axis, not the line y equal to some beta, right? So does there exist a beta for which the line y equal to beta intersect the curve at infinitely many points? So let us see. See, y equal to beta. See, conveniently we can choose the value of beta to be 0. If beta is 0, okay, if you choose the value of beta to be 0, that means y equal to 0, that is x-axis only. So x-axis only. Now what is the graph of only this portion? I'm saying this portion. So y equal to 0, that means the whole thing is equated to 0. So what is the graph of this thing? So obviously this will go up and down, right? So some values it is positive, some values it is negative. So that is the graph of e to the power minus x. What is the graph of e to the power minus x? So that starts from okay, so at 0 it is at 0, so the value is something, right, some positive value, right? If you take it to the other side, positive value, and then it will keep on decreasing, and then at infinity it will become 0. Okay, exponential function, it decreases like this. Now, so how many intersections are there? Obviously there will be infinite intersections, right? Because this is a periodic function, the same graph will repeat till infinity, and that is a function decreasing and it reaches 0. So obviously it will intersect this graph and this exponential function. These two curves intersect at infinitely many points, particularly for beta equals 0, which means there exists some value. Not only 0, there are many more values, right? If you take values close enough to 0, so there are many points, infinitely many points, so which are intersections of this function and this thing. So infinite intersections are there, so that must be the answer. Here we have 4 boxes, each containing 3 red balls and 2 blue balls. We have to select 10 balls from these boxes, but minimum 1 ball has to be selected from each box, right? 1 blue ball and 1 red ball should be selected. See, it is like this. See, this is the first box. The first box has 3 red balls and 2 blue balls. Similarly, second one. So that also has 3 red balls, 2 blue balls. Okay, so third one, 3 red, 2 blue, and fourth one, 3 red, 2 blue. Now we have to select now 10 balls, okay, which means from each box we have to select 1 red, 1 blue. That means minimum 1 red ball is selected from this and minimum 1 blue ball is selected from this. So from each one we have to select 1 ball minimum. So that means totally how many balls? So 8 balls are already selected. 8 balls are selected. Now 2 more balls we have to select. So these 2 balls can be selected from which box, which color. So that's what matters, right? So we have to consider different cases. Okay, yes. Now let us consider the first case. The first case in which the 2 balls selected, right, are from the first box and both are red balls. That means 2 balls are selected. So not 2 balls, already 1 ball is selected. Now 2 more balls, which means totally 3 balls we are selecting from the first box and that too red. Okay, which means now we are not selecting any more balls from the other boxes. Okay, that is the first case. Now what is the second case? What are the other possibilities? Now also we selecting 2 more red balls only, but not from the same box. 1 red ball from this box, 1 red ball from this box. Okay, so like this, 1 red ball extra. Okay, already 1 red ball selected plus 1 more and no blue balls, and here 1 red ball again. So now from this no balls. Now next case. What is the next case? Now red ball is done. Now we have to select blue balls only. Okay, 1 red ball, 1 blue ball. Okay, 1 red ball is selected. Maybe from the first box, okay, any one box, 1 red ball is selected and 1 blue ball is selected. Okay, so maybe from the first box itself, so anyone, so 1 blue ball is selected. Now no more balls from the other boxes. Okay, done. Now one more case. Okay, so now we are selecting both the balls, right? The 2 extra balls, both are blue only, not red. So red case is done. So both are blue balls. So that means no ball here. But both the blue balls cannot be selected from the same box because already 1 ball is selected, only 1 blue ball is left here. So now 1 ball from one of the boxes and another ball from this box, say. Okay, now like this. So these are the 4 cases we have to consider. Okay, let us do it one by one. So the first case. So what is the first case? Now 2 balls are selected plus already 1 ball, which means totally 3 balls are selected from the first box from the red. Okay, yes, that means from 3 red balls we are selecting 3 red balls. So how many ways that can be done? So that is 3C3. Okay, done. Now from the 2 blue balls, okay, we are selecting only 1 ball. From 3 red balls we are selecting only 1. So which means 3C1, 2C1, 3C1, 2C1, etc. Which means 2 multiplied by 3 times 2 multiplied by 3, etc. Which means how many times 2? 1, 2, 3, 4, right? 2 to the power 4. Okay, I am writing directly actually 2C1, 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 so that means 2 to the power 4 multiplied by how many times 3? 3C1, 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 so 3 times 3, so 3 to the power 3. But this should be multiplied by, see, we are selecting 3 red balls from one box, no? But which box? It may be first box, we have considered only the first box, but it may be from the second box, third box or fourth box. So that means any one of the box can be selected. So that is also multiplied by 4C1. Okay, so that's all. Let's simplify this. So 3C3 is 1. So 2 to the power what? Here 2 square. So 2 to the power 6 multiplied by 3 to the power 3. So that is the total number of cases, right? So that is only the first case. Okay, now similarly we will do the next case, second case. What is the second case? Now here from the first red ball, okay, first red ball, 3 red balls, we are selecting 2 red balls because already 1, now 1 more. So 3 red balls, it means 3C3, 3C2. And okay, similarly here also 3 red balls, we are selecting 2 red balls, so 3C2. From the remaining boxes, we are selecting only 1 ball, right? So from 2 black balls, blue balls, we are selecting only 1 plus 0. And similarly here also only 1, 2C1, 2C1, 3C1, etc. So how many times 2? 2, 1, 2, 3, 4, which means 2 to the power 4. And how many times 3? So here, this is already counted, so 3 square. And now this should be multiplied by various combination. Now we have selected only first box and second box, right? From the first box we are selecting 2 red balls, second box we are selecting 2 red balls, but it may be second and third, it may be fourth and first, so many possibilities. So 4C2, right? So 4C2 should be multiplied by. From the 4 boxes we are selecting 2 boxes from which we are selecting more number of red balls. So 4C2 is to be multiplied. Okay, so let's simplify this. So what do you get? 3C2 is 3, again 3, so 2 to the power, what is the 4C2? 6 we have a 2, so 2 multiplied by 2 to the power 4, so that is 2 to the power 5. And how many times 3? So 1, 3, so 3. and 3 square, so it means 3 to the power 4, and here also we have a 3, so 3 to the power 5. So this is the second case. Okay, now we will do the third one. Okay, so what is the third one? So here we have 1 plus 1, 2 red balls from the first, so 3C2. Okay, and so 2 blue balls from these two, that means 2C2. And from the remaining we are only selecting 1. Okay, yeah, remaining they are selecting just 1, which means 3C1, 2C1, 3C1, 2C1. So 3 to the power 3 multiplied by 2 to the power 3. Again this should be multiplied by, see, we are selecting 2 red balls from one of the boxes. Which box? Any one box we can select, so 4C1. Similarly, the blue balls also we are selecting from the first box, we are selecting 2 blue balls. It may be second or third or fourth, so that means again 4C1. So let us simplify this. Okay, so how many times 2? So 2C2 is gone, so 3C2, so that is 3. So 2 cube here, 4, 4, so that is 16. So 16 means 2 to the power 4, so totally we have 2 to the power 7 multiplied by, how many times 3? So 3 cube, so that is 3 to the power 4, yes. Now last case. Now here blue ball, okay, 1 blue ball. So here 2 blue balls, we are selecting 2 blue balls, so that means 2C2. And here 2 blue balls, sorry, yeah, here 2 blue balls, we are selecting 2, so 2C2, 2C2. So 2C2, 2C2, and from the remaining boxes just 1, so 3C1, 3 to the power 4 multiplied by, so 2, so 2 square. Now again this should be multiplied by, we are selecting 2 boxes, right? So these 2 boxes are selected, so that might be any 2 of the 4 boxes, so 4C2 is to be multiplied with this, so that equal to, how many times 2? So these 2 are gone, so 2 square, here also we have a 2, so 2 cube multiplied by, so 3 to the power 4, here also we have a 3, right, because it is 6, so 3 to the power 5. Okay, so that's all. This total should give you the answer, so let us calculate that. So from this, what can you take out as a common factor? 2 cube maximum, and then 3 to the power 3 maximum. So 2 cube multiplied by 3 cube, if you take out, so what do you get? This is 2 to the power 3, okay, 8 plus, so 2 cube, 3 cube, so that is taken out, so that means 2 square, 3 square. 2 square is 4 multiplied by 9, so that is 36 plus, now 2 cube, which means 2 to the power 4, right, 2 to the power 4, that is 16 multiplied by 3, so that is 48 plus last one 2 cube, so 3 square, so that is 9. Okay, so that's all. So this should give you the answer. So this is 6 cube multiplied by, so what is this value? So 8 plus 36, right, so that is 44 plus 48, so 92 plus 1, so 101. Okay, so 216 multiplied by 101, which means 21600 plus 216, which means 2160, okay, multiplied by 100, okay, plus 216, so what is that? 21816, so this should be the answer. Let's check whether this is there. 21816, so that is a required answer, right? See, so many cases we are considering. See, already we have selected 1 from each box, that means only 2 more balls have to be selected. For these 2 balls we have to consider many cases, right? So from which box the 2 balls are selected, or from which color, right, it is selected, so that gives rise to 4 cases, so we are considering one by one, right? So this is the answer. Here a matrix M is given, we have to find M to the power 2022. Obviously we are not going to multiply M 2022 times, we have to observe some pattern, right? So the matrix M is given, so that is, so this is the matrix M, so that is, say, 1 by 2 can be taken out, 5, 3, minus 3, minus 1. Okay, so this is the matrix M. Okay, now one method is to relate this matrix M with the identity matrix. Identity matrix plus something equal to M. So that way we can do it, but let me do this by a different method, I mean direct method, right? M to the power 2022, right? First let us find M square or M cube, then we can generalize it. Okay, let's see. So what is M square? So M square equal to, so 1 by 4, then 1 by 2 multiplied by 1 by 2, and then 5, 3, minus 1, multiplied by the same value 5, 3, minus 1. Okay, so this gives you the value 1 by 4 multiplied by, so what do you get? 5, 25 minus 9, so that is 16, so that is 15 minus 3, that is 12, then minus 15, so minus 12, then next one is minus 9, yeah, so this is minus 9 and plus 1, so minus 8. Okay, now if you divide by 4, you'll get 4, 3, minus 3 minus 2. So this is the matrix m square. Now this m square to the power 2022, no, m square to the power 1011, that's what we have to find. Okay, so m square to the power 1 is known. Now what do you do? So m square, alright, so you square this, m square the whole square, which means this is multiplied 2 times. Okay, 4 3 minus 3 minus 2 and 4 3 minus 3 minus 2. Let's see what you get. Okay, so 16 minus 9. Okay, so this is 16 minus 9, so that is 7. And then 12 minus 6, so that is 6. Similarly, minus 12 plus, okay, minus 6. And then minus 9 plus 4, so that is minus 5. Okay, so we've got something like this. So m square square, but what we want is m square to the power 1011. Okay, now so m square to the power 101, that's what we want. Okay, the square power is 2, then we have 7 6 minus 6 minus 5. So one thing we can observe is this is one number, this is one less than that, and same number with the negative sign, and this is one less than that. Okay, so like that, this is the pattern. So if only one option satisfies something like this, then that will be our answer. But if you look at this, all the options are like that only. 3034, next number is one less than that, so now that is of no use. Now we have to observe this. For 2 we have 7, and for this 2 we have 6 here. What is this 7 6 minus 6 5? Okay, what is this 7? Can you observe this, what this 7 is? So that 7 is, so this 3033, what is 3033? 3 times 1011. Okay, 3 times 1011. Okay, so from that we should try to observe some pattern. Okay, so what do you get? Tell me. See this 6 here, so this 6 here is something, either this 6 is 2 times 3, 2 times 3 is 6. Okay, now what is 1011 times 3? So that is 3033. Okay, so that is possible, right? One possibility. So because 2 here, from the options only we observe the things. So here 3033 and the number we got is 1011, they are related directly. What is the relation? 3 times. So similarly here also we observe the same pattern. Here 2, this is 3 times that number. Okay, so that means what comes here, this position, so that is 3 times this number. So what do you do? Here 1011, so that means this number must be 3 times that, which means 3033. And what should be this number? 1 more than that, which means 3034. And this number is negative of that number, so that means minus 3033. And this number is, okay, again 1 less than that. Okay, so minus of, okay, 1 more than that actually, 32. Okay, now if this option is there, so that is it, our answer, right? Yes, let's see. 3034, 3033 minus 30. Okay, so that means, so that is the first option, right? So that is our required answer, right? This is one of the methods. So this is very simple. We just found m square and m square to the power 1011. Observing this pattern, you found it directly. Or you can relate this with the identity matrix, and then we can do that. But it's very difficult to get that idea how to relate this matrix with the identity matrix. But here, nothing, right? Simply we found m square and we observed some pattern and we got this answer. Okay. Yes. Here 4 boxes are given having different colored balls, right? The first box contains 8 red, 3 blue and 5 green balls. Now one ball is selected from the first box. Now if that ball is a red ball, now the second ball is selected from the second box. If that ball is blue from the first box, now you have to select the second ball from the third box. The first ball is always selected from the first box, but the second ball may be selected from the second box or third box or fourth box depending upon the color of the first box. First ball, right? Yes. Now let us consider the cases. We have to find the probability that among the 2 balls selected, 1 ball is white, but it is a conditional probability, not total. The sample space is the number of cases in which among the 2 balls, 1 ball at least is a green ball. So that is the sample space. It's a conditional probability. That means what comes in the denominator or the sample space is the number of cases in which among the 2 balls at least 1 ball is a green ball. So that means what are the various possibilities? Yes, so this comes in the denominator. The first ball is green, the second ball may be, see, first ball is green, obviously we are going to select the second ball from the last, okay, fourth box only, which means second ball may be green. So first ball is green, second ball may be green. Okay, that is one possibility. Okay, what are the other possibilities? The first ball may be green and the second ball is orange, and the first ball is green, the second ball is white. It is not possible that the first ball is green, the second ball is red. Not possible, because when the first ball is selected from the first box, green ball is selected, we are going to select the second ball only from the last box. That does not contain any red or blue balls. So these are the only possibilities. The first ball is green. What are the other possibilities? The first ball is red. Suppose the first ball is red. Maybe the second ball is green. Possible. Okay. So first ball is red, second ball is green. So that is possible. And the first ball is red, blue. First ball is blue. And then the second ball may be green again. Okay. So that is possible. So one of this must be green. Remember. So one of them, either first one or second one, must be green. I think these are the only possibilities, right? Yeah. So these are the only possibilities. Yes. Now, among this, which is our favorable case? Favorable case means what? One ball must be white. Only one case, green, white. So that is coming in the numerator. So this is a favorable case out of the total cases. Okay, that's all. So write the probability, that is our answer, right? Just calculations now. So green ball. First is green, second is white. What is the probability? What is the probability that the first one is a green ball? So 5 green balls out of how many? 16. So 5 by 16 from the first box. So 5 by 16. That means first ball is green. That means you have to select the second ball from the last box. So that has 10 green balls and 16 orange, 6 white. So what is the probability that the selected ball is white? So that is 6 white out of total. So what is the total? 10 plus 16, 26 plus 6, 32. So this is the probability out of total. First green, second also green. First green, what is the probability? 5 by 16. And first is green, then we have to select from the last box. So second is also green. So what is the probability? So 10 divided by 32. Plus first is green, that means 5 by 16. Okay, second is orange. How many orange? 16 orange out of 32. So 16 divided by 32. Plus next one, green white, that is in the numerator also. So 5 divided by 16 and 6 by 32. Okay, now next one. So red, green. First one is red. What is the probability? 8 out of 16. 8 by 16. Red means you have to select from the second box. So second box we have to select green. So 15 out of, so total is what? 15 plus 9. So that is 24 plus 24, 48. So that is 15 by 48. 15 by 48. Plus the next case, when first one is blue, the second one is green. So first one is blue. What is the probability? 3 divided by total 16. So 3 by 16. Now first one is blue, which means we have to select the second ball from the third box. So that is green. So how many green balls? So 12 green balls out of 16. So 12 divided by 16. Then just calculation. Okay, multiply both numerator and denominator by 16 times 16. So if you do 16 times 16, so this 2. So 6 by 2 is 3. 3 multiplied by 5. It is 15 divided by, so 5 times 5, 25. 16, 16. So that means 2. So 8, 5. So that is 40. And then, so here also 2. So 3 times 5. So 15. Plus here 3 times 16. So 3 is cancelled. So 5 multiplied by 8, 40. Plus last one, 16, 16 cancelled. So 3 times 12. So that is 36. So let us simplify this further. So it is 15 divided by, so 25 plus 15, 40 plus 40, 80 plus 40. So 120 plus 36. So 156. So that's all. So that is the answer. I think we can further divide this by 3. Okay. So it is 5 divided by, if you divide this by 3, so it is 5, 2. Okay. 5 by 52. So that is the required answer. That's it. This is a question on limit of sum. We have to find the value of this series using integration. So the first term here is n. N is not the first term. 16 plus 5n etc. That is the first term. Now n should be removed. So how to remove this n? We can write this n as 1 plus 1 plus 1 n times, and then we can add 1 with each term of this series, right? So that is the way we can remove this n, right? N is distributed over the entire series, right? So the first term will become, so t1. So that is the first term. So term number 1. So that equals 16 plus 5n minus 3n square divided by 4n plus 3n square plus 1. We are adding 1 with the first term. So that becomes 16, 5n plus 4n. So that is 9n. 3n square gets cancelled. So divided by 4n plus 3n square. So this is the first term. So similarly, we'll find the second term. With the second term also, we'll add 1. So we'll get 32 plus n minus 3n square divided by, so 8n plus 3n square. So with the second term also we'll add 1. So that becomes, so 32. So n plus 8n, so that is 9n, so 3n square again gets cancelled, so this is 8n plus 3n square. This is the second term. Now we have to generalize it. If you want, you can find one more term, t3, so but this is enough, right? T1, T2. Now we have to generalize it. We will find the rth term of the series, right? So what is the rth term? So here you see, so 16, so here 32, so isn't it like arithmetic progression? 16, 32, next will be 48, so 16 times 1, 32 times, 16 times 2, so general term, the rth term here is 16 multiplied by r. Okay, so next, so here 9n, so 9n, so that is same, so 16r plus 9n, so that is the numerator and denominator here. So the first term here 4n, now 8n, so next will be 12n, etc. So that means again it is a multiple of 4. Okay, 4rn, okay, and then 3n square as it is. That's all. This is the rth term of the series. Now we have to find the sum. So this sum of r from 1 to n, okay, then we have to find the limit, okay, limit of this sum. So limit n tending to infinity. So let's take this n out, right? So similarly here we can take n square out, right? So that is the method to do questions of this type, right? We have to get 1 by n and also r by n. So if you take n out, so that is n 16 r by n plus 9 divided by, so this is 4, again n square is taken out here, so n square if you take out, so this is 4 r by n plus 3. Okay, now as usual, so okay, so now we will write this limit summation as integration, right? And then this r by n becomes x, and then 1 by n can be written as dx. So this limit summation can be converted into integration. So that becomes integration of 0 to 1, and then this 16 r by n, so that becomes 16x then plus 9, so divided by 4x plus 3, and then this 1 by n can be written as dx. So now it is a question of integration. So let us simplify this. See, both this numerator and denominator are linear functions. You can write the linear function in terms of the denominator linear function, right? So 16x, so that can be written as 4 multiplied by 4x, right? 16x. So 4x plus 3, we need plus 3, so plus 3, so we add 3, so that means it is 16x plus 12, but what we have is 16x plus 9 only, so that means we have to subtract, so this 12 minus 3, so divided by 4x plus 3. Okay, yes, now we have to divide. Actually we are dividing, that's all. So 4 integration of 4 plus, okay, minus 3 divided by 4x plus 3 dx. So now we can do the integration here. So this is 4x and this is minus 3 by 4, this is log, okay, log of 4x plus 3. Now the limit is from 0 to 1. Okay, yes, now if you substitute the limits 1, so we get 4 minus 3 by 4. Now if you substitute the upper limit, we get log of 7, and lower limit log of 3. So log of 7 minus log of 3, so that can be written as log of 7 by 3. Okay, so that's all. So that is our required answer, right? So the value of this integration, and that is the value of the limit of the sum, right? So this is the answer, 4 minus 3 by 4 log 7 by 3. Okay.